Greetings everybody. This video will hopefully explain how to do problem 3 on these homework problems involving, well, they're not really homework problems in the sense I'm grading them. They're just homework problems for you to work out, on your own so you understand the material. Okay, so problem 3 is it's a very common Newton's second law problem, typically called a connected mass problem. And notice M1 and M2 they're connected via a frictionless, but they're connected by a string that passes over a frictionless pulley. That tells us we don't need to reinvent the wheel. That tells us right away that the tension in each string, in other words, the tension on M1 and the tension on M2, we know those two tensions are the same because the pulley is frictionless. Now the table is frictionless, so that makes our lives a little bit easier. We don't have to worry about, FK or FS. There's no friction. And the M1 has a mass of 5 and M2 has a mass of 9. So most likely when the system is released from rest, M2 will accelerate in the negative y direction, and that will mean that M1 will accelerate in the positive x direction. And we want to find the magnitude of that acceleration, and then we want to find the tension in the string. Because again, we know the tension on M1 and the tension on M2, they're the same. We'll call it T. All right, well, let's go ahead and let's draw. So what we want to do is we're going to draw all the forces acting on M1, all the forces acting on M2. Then we're going to apply Newton's second law to M1 and apply Newton's second law to M2. Let's go ahead and do that. Now notice a little shortcut here. Let's start with M1, and then we'll get to M2. Well, again, see these dotted arrows here? One here, and that's indicating that is not a force. That's where I'm indicating the direction of the acceleration for each object. This means that, hey, M1 is accelerating in the positive x direction. Down here, I'm saying, hey, M2 is accelerating in the negative y direction. That's what those two parts of the diagram mean. Now let's draw all the forces acting on M1. But I only need the forces in the x direction. I don't need the weight and the normal force. They do exist, but for this problem, I don't need them. Why? Well, because there's no friction. Remember, what is friction? Whether it's kinetic or static, friction is coefficient times normal force. Fs is mu s times Fn. Fk is equal to mu k times Fn. But there's no friction. So I don't really need Fn. Also, I don't need it because M1 is not moving. In terms of the y direction, it's in equilibrium. So it is of no use to get for M1, Fn and Mg are not of any use in terms of getting A. Why? Because A is in the x direction. So remember, frictionless. So the only force acting on M1 in the x direction is the tension force. Remember, the tension force is always directed along the string, but away from the object. So for M1, T is pointing in the positive x direction. That's it. So I've drawn, that's the force acting on M1 is T. Now let's draw the forces acting on M2. Well, there's the weight, M2G, which is in the negative y direction. And there's the tension force, T, acting in the positive y direction. Again, why? Because the tension force is directed along the string, but always away from the object. That's the pulling force. Why do I know these two tensions are the same? Because the pulley is frictionless. Okay, so I've drawn all the forces. I know that M2 is accelerating in the negative y. M1 is accelerating in the positive x. Well, let's apply Newton's second law first to M1 and then to M2. Now in M1, I apply Newton's second law in the x direction. For M2, I'm going to apply Newton's second law in the y direction, because those are directions respectively that M1 and M2 are accelerating. Well, remember, in general, again, dealing with M1, in general, it's the sum of the forces in the x direction equals M times AX. Well, there's only one force in the x direction, T. So let me pause it here for a second. Okay, so going back. So remember, in Newton's second law, in component form, these are from the previous lecture notes. We don't need the z, but the sum of the forces in the x directions equals the mass times the acceleration in the x direction. The sum of the forces in the y direction equals the mass times the acceleration in the y direction. So we're going to apply the x equation to m1 and then the y equation to m2. So what's the only force acting on m1 in the x direction? It's the tension. So that sum, when we say the sum of the forces in the x direction, that's just t. And so t must equal m1 times a. Remember, sum of the forces equals mass times acceleration. So t equals m1a. I'll call that equation 1. Now likewise, let me do the same to m2. Now there are two forces acting on m2 in the y direction. m2g is negative, t is positive, and we know that the acceleration of m2 is negative. So we could write it as t minus m2g equals minus m2a, or more preferably, let's write m2g minus t equals m2a. Because as long as m2g and ma, they need to have the same sign, and in this case, they're both positive, and in this case. So it's preferably to write it, instead of writing t minus m2g equals minus m2a, mathematically this is exactly the same, and this is preferable. So that's equation 2. m2g minus t equals m2a. Just think of it. m2g minus t equals m2a. So I have equations 1 and 2, and remember our goal is we want to solve for the acceleration, and then we want to get the tension. We want the acceleration A, then we want the tension T. Well, this is a very common technique. So I have two equations, two unknowns. My two unknowns are A and T, and I have equation 1 and equation 2. What if I just add equations 1 and 2, meaning add left-hand side to left-hand side? Yeah, just add left-hand side to the left-hand side, and meaning you have to add the right-hand side to the right-hand side. Well, if I add 1 and 2 on the left, I get t plus m2g minus t. Notice on the left-hand side, the t's cancel. I have a t and a minus t. So I'm left with m2g. Now on the right-hand side, I have m1a plus m2a, i.e., in parentheses, m1 plus m2 times a. So when I add 1 and 2, I get equation 3. I get m2g equals m1 plus m2 in parentheses times a. How to solve for a? Divide both sides by the term of parentheses. I get a is equal to m2g divided by m1 plus m2. G is 9.80 meters per second squared. M2 and M1 were given. M2 is 9, M1 was 5. Plug in those numbers, you get the acceleration is 6.30 meters per second squared. Now to get T, you could use equation 2 or equation 1. I'm going to use equation 1 because it looks like a much easier equation. Because right away, T is M1A. Where M1, remember, M1 was 5 kilograms and M2 was 9 kilograms. But equation 1 tells us T is M1A. So it's just 5 kilograms times 6.30 meters per second squared. And you get 31.5 newtons. But again, this is a very common problem. We'll do another one later where we have 3 connected masses. And we're going to have 3 equations. We're going to have an M1, an M2, and an M3. So we're going to have 3 equations. But you add them up, add left-hand side to left-hand side, right-hand side to right-hand side. You'll see the tensions will cancel. It's a very common technique. It's not some trick that I made up. And that's a very common algebraic technique. When you have these 2 equations, this is equation 1, this is equation 2. So just add equation 1 plus equation 2. And you get on the left-hand side, you get T plus M2G minus T. So you get M2G. On the right-hand side, you get M1A plus M2A. i.e., in parentheses, m1 plus m2 times a. Divide both sides by the term in parentheses, and you're done. Alrighty, let me go ahead and save this video and get it posted.